Hi, I'm Alex Arujo, and today I'm going to be talking about my project on Kirchhoff's voltage law. I have made 3 circuits that are going to be used to demonstrate this law. The first circuit that I have here includes a 1k ohm resistor, a 470 ohm resistor, and a 2.2k ohm resistor, with a supply voltage of 9 volts. Throughout this circuit, as demonstrated in the circuit diagram here, each component will consume a certain amount of voltage, with the 1k ohm resistor consuming a portion, the 470 ohm resistor consuming a portion, and the 2.2k ohm resistor consuming a portion. This can be visualized in this graph representation over here. You can see that the supply voltage starts at 9 volts, then drops down to around 6.5 volts after the 1k ohm resistor consumed a portion, which then eventually drops down to around 5.3 volts, indicated here, and that portion was consumed by the 470 ohm resistor, and the remainder 5.3 volts is consumed by the 2.2k ohm resistor. The third circuit here, consisting of one 470 ohm resistor, 2 red LEDs, and one 5/10 of an inch yellow wire, follows this circuit diagram over here, with the 9-volt power supply, 1 red LED, the second red LED, and the 470 ohm resistor. Kirchhoff's voltage law in this situation can be represented as a graph, as seen here, with a starting voltage of 9 volts, then dropping down around 2 volts to 7.2 volts, then dropping again another chunk down to around 4.3 volts, then finally the remaining voltage is consumed by the 470 ohm resistor, bringing down the total voltage to 0. This can be represented mathematically with this general formula for Kirchhoff's voltage law, which can be rewritten as this, and then you can plug in your different variables, giving you the equation 1.99 volts plus 1.99 volts plus 4.26 volts equals 8.6 volts, which is your starting voltage. This circuit here, consisting of one diode, one 470 ohm resistor, and one blue LED, along with an orange 4/10 of an inch wire, follows this circuit diagram here, with this being diode, this being the resistor, the 470 ohm resistor, and this being the light emitting diode. Through this circuit, you can see that the current can only flow one direction through this diode, flows through the resistor, and can only flow in this direction through this LED, in turn lighting it up as blue. This graph here shows the voltage drop across the different components, with the starting voltage starting at 9, then dropping down to around 8, the voltage consumed by the diode, then dropping down to around 4.2, which is consumed by the resistor, and then finally dropping down to 0, with the remaining voltage being consumed by the blue LED. Again, Kirchhoff's voltage law is applicable here, with this being the general equation, which can then be written out as this, and in this case is applicable to this, with your first measurement, 3.72 volts, plus 0.69 volts, plus 4.04 volts, equaling this starting voltage.